Hey guys, so today we're going to do 8.2, which is rate of change. This is day 4 in your OneNote. Today's learning goal is I can determine the rate of change of a linear function. Let's look at our first example. Find the rate of change of the linear function that models the height of the zip line. Remember in our previous lessons, we talked about m being the slope. It's also known as our rate of change. We talked about slope helping us identify that from a graph would be rise over run. So from the graph that we have here, we're going to implement our rise over run. So looking at where our graph starts at the top, reading everything from left to right, we go down by a slant of decreasing. From 250 to 200, we went down by 50 spaces. Then, as we go over, and we do our run, we go over a total of 300. So in writing our rise over run, our rise would be negative 50 over our run, which is positive 300. By reducing this fraction, we reduce to 1 over 6. All right, our next example says, what is the rate of change of the linear function that models the top of the truck? So we're looking at the top of this truck here in green. I'm going to highlight it over with yellow. If we have a rate of change and nothing is changing, our slope or our m value, oh gosh, Ms. Jones can't spell today, guys. So our slope is going to be constant. That means that our slope is at 0. Okay, so all of this information here we've discussed a lot in class. I just want you to highlight everything that I highlight. So the rate of change, you've seen this on your index card. Oops. Rate of change is simply the vertical change or the horizontal change. Or we know it as the change in y over our change in x. So when you think about this over here on the right side with our graph, we go up 6, which is our rise, and then we go over 3, which is our run. That's how they get the value of 2. The rate of change between the 2 points, -1 and -1, and then the other point that's valued 2,5 is simply 2. Therefore, our rate of change, which is also known as our m value, would be considered 2. Identify the equation of each linear function shown at the right. Then state the rate of change of the function. So first we're going to do the graph and then we'll do the table. Remember that off to the left here we have a bunch of choices that we could choose from to match our graph with our equation. So remember, we talked about in class, y equals mx plus b. B is your y-intercept, and m is your slope. So for our graph, let's start at where we see the y-axis intersect with our graph. This value is considered 3. So we know that our equation, our b value, has to be 3, which means we can eliminate these bottom 2. Now we need to figure out what is our slope. So if we go do our rise over run, if we go down, how many units would this be? 1.5, and go over 0.5, we have our rise over run, which would be negative 1.5 sorry, I forgot to put the negative there, over 0.5. Well, when you divide these, negative 1.5 divided by 0.5 gives us a value of negative 3. Therefore, if our b value is 3 and our m value is negative 3, our equation would read y equals negative 3x plus 3. Our rate of change, which is, remember, our slope, would be considered negative 3. Okay, now let's look at the table over here in the orange. So remember we did in class yesterday, we talked about how we could substitute our x values into our equation to see if both sides balance. Well, we know that the second equation is not going to work because we already chose it for our graph. Let's try using our ordered pair 0, 0 to substitute for our x and to substitute for our y. So what happens if we do the first equation that says y equals 3x plus 3? Well, if I let y equal 0 and I let x equal 0, 0 does not equal 3. So I know that this equation here is not going to work for me. Well, what if I did y equals 1 over 3 times x? Well, I could do 0 for y equals 1/3 times 0, which means that 0 does equal 0. That's great. But what if we just tried one of our other problems? Let's choose a positive one here. What if we substituted again for our y, the value 2, equals 1 over 3 times, I'm sorry, I did this backwards. Let's substitute our y value, which is 2 over 3, equals our x value, which our value is 2. If we multiply these, 2/3 stays the same, equals, let's put our 2 over 1. 1 times 2 is 2. 3 times 1 is 3. So it checks out. Therefore, our equation for our orange table would be y equals 1/3 x. Well, our rate of change, remember, is our slope. Our rate of change would just be 1 over 3. All right, let's look at another example. What is the rate of change of the linear function y equals 3 over 2x minus 2? Again, remember, guys, y equals mx plus b. M is always going to be your slope. So in our case, our m value is just 3 over 2. All right, our last example. Use the values for a 1 ounce candle and then a 5 ounce candle. Okay, some technical issues. Use the values for a 1 ounce candle and a 5 ounce candle to find the rate of change for the data in the table. What does the rate of change mean in this situation? So we're using the information here for our 1 ounce candle and how much it burns over time, and our 5 ounce candle and how much it burns over time. So we're going to find the rate of change, which again is going to be our m value. So the rate of change, m equals the change in y, this is also in your spiral notebook, over the change in x. So in our case, the change in y would be 27.5 minus 5.5. Hence, our weight of candle is our x value, the burning of the candle is the y value. So change in y over the change in x, which would be 5 minus 1. 27.5 minus 5.5 is simply 22 over 4. When you divide 22 over 4, you get 5.5. So to explain this just simply means that for each additional ounce of weight, a candle burns an additional 5.5 hours. Alright guys, that's it. 8.2 digits what we'll do tomorrow in terms of our homework or our class assignment. If you have any questions, please remember to ask me tomorrow. See you guys tomorrow.